Hi there, this is Qian. It is my great honor to share with you my PhD dissertation titled Profiling AI as a Material for UX Design. This dissertation centers around one question. What makes human AI interaction seem particularly difficult to design? Some say it's because AI algorithms are complex, they rely on big data, they make unpredictable errors. But HCI routinely grapples with complex, resource-intensive technologies that make unpredictable errors. What makes AI unique? Or is it? To what extent can existing HCI methods and knowledge address AI problems? Throughout my PhD, I wanted to explore this question, and to do so, I designed various kinds of AI systems across application domains. And here is my synthesis and my initial attempt in articulating whether, when, and how human AI in action is uniquely difficult to design. Think about the lifetime of an AI system, say a recommender. It first gets trained on some training data, and then it continues to learn from new user-generated data post-deployment. And when the user uses it, it takes in new runtime inputs and provides personalized and context-aware outputs. Now, of course, the user-generated data across these contexts are really a small fraction of the user needs and desires and thought processes and behaviors that we're dealing with here. In this context, so against this framework, we can see that when we're designing a particular moment of human AI interaction, we're really dealing with many stages of interactions that occurred over time with different groups of users. And we're dealing with a lot more moving parts here. People say that the most remarkable technologies are like electricity. They do exactly what users expect them to do, such that they fade into the background of people's everyday lives. But in AI, it's already kind of difficult to match algorithmic capabilities and user needs at large. It is really difficult to fine-tune and orchestrate every moving part in this diagram in order to create an AI that fades into the background of people's everyday lives. How can we innovate prototype AI systems like this and account for their errors and unintended consequences? And I think these are the core challenges of human AI interaction design. Now, this framework also gives us some hope. It gives me, at least, a new perspective into how we can tackle these challenges. For example, in clinical AI, clinical AI systems typically do not learn from user-generated data live. And therefore, clinical AI is really actually a great entry point to study human AI interaction issues like explainability and collaboration. We're dealing with fewer moving parts here. Now, when it comes to designing AI systems that continue to learn and evolve with users, we're already seeing new design methods and processes in the industry and in coping with all these new challenges around designing AI as a living system, as a system that continues to evolve and co-live with users. It is in this context that I wrote this dissertation, and it describes this framework and a number of real-world case studies like the AI assisted in writing and clinical AI use cases, as well as observations of this new practice. Hopefully, this dissertation can serve as a useful reference for the many AI and HCI researchers moving forward.